Greetings and welcome. This is Dr. B.D. Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be seeing the main problems, important problems in the tutorial question bank submitted for course Engineering Mechanics. Before going to the problems in friction, let us first understand the basics or recollect the basics in friction. We have discussed that when two objects are in contact with each other and one object tries to slide over the other object, there exists a resistance for the motion. This resistance in the contact surface or contact area is called as the friction. And we have detailedly understood that whenever the object is moving in one direction, the friction at the contact surface will be acting in the opposite direction to the movement of the object. So whatever direction the object is moving, friction will act opposite to the movement of the object. And there exists a normal reaction which is normal to the object and it will be towards the object. So the normal reaction will be normal to the plane in contact and towards the object. So this would be represented with and the inclination to the resultant reaction and the normal reaction is called as the friction angle. And this friction angle, the tan friction angle, is given as the coefficient of friction, which is mu, represented with mu. So these are the basics which we need to understand before doing any problem. So now let us go to the problem. The problem given is a body of weight 150 newtons is lying on a rough horizontal surface. Okay, so here in this problem there is no figure given. What we will do is first let us draw the figure for the given conditions. So let us see, there is a body of weight 150 newtons. So let us consider this as the body which is lying on a horizontal surface. This is the horizontal surface on which 150 Newton body is been lying. So this 150 Newton, the weight of the object will always act vertically downwards direction. So this 150 Newton will be shown like this, and it is given that the contact of this body with the horizontal surface is a rough contact, and the coefficient of friction, that is the value of mu, is given as 0.25. Then find the magnitude of the force which can move the body, right? So understand another thing, that this is the concept in static friction, that is this is the concept in the static part of the mechanics. So there won't be any movement of the objects anytime. Here the question is being asked that the object will tend to move. That means the motion will impede. It will just start. So all the conditions which we are going to see is about the motion that will tending to start. There won't be any real motion, but it will try to start. It will tend to start. So the motion will impede. So here the question asked is, find the magnitude of force which can move the body while acting at an angle 50 degrees with the horizontal. Right? So let us say there is a force that is being applied onto this object, and the inclination is given at 50 degrees. So let us consider that force to which the magnitude should be known as P. So this is the problem given. So we need to identify the magnitude of P. So here it is asked that find the magnitude of force which can move the body while acting at an angle 50 degrees with the horizontal. So the force is being acted at 50 degrees to the horizontal onto the body. So we have applied that force P as shown here. So this is the problem given, and the figure for the given problem is being drawn here. So let us start to solve the problem. Before starting the problem, let us understand that the condition of equilibrium holds in this system, wherein all the objects that are in static condition, we are going to apply the equilibrium equations conditions, that is sigma fx is equal to 0, sigma fy is equal to 0, and sigma m is equal to 0. So these are the conditions of equilibrium. So we need to apply all the sum of all the horizontal component forces is equal to 0, and sum of all the vertical component forces is equal to 0. So here in the given problem, there are two forces as given. One is 150 Newton force which is acting vertically downwards, and P, the force P, which is acting at inclined condition. That means this force which is acting in inclined condition should be resolved into mutually perpendicular components. So that resolution can be given like this. This is the force P which is acting at an inclination of 50 degrees. So for this, the mutually perpendicular components would be starting from here, we can come down. This would be vertical component, and from here we can go to the right side. This would be horizontal component. So writing the magnitude of these components, this horizontal component would be P cos 50, and this vertical component would be P sin 50. So in this way, we can say that there are two vertical forces and one horizontal force. Two vertical forces and one horizontal force that is given in the system. Now, other thing which we need to consider is, it is given that the plane is rough. That means at the contact surface here, there exists friction. And we can understand that as the force is being applied in this direction, that is the force P which is acting from left to right hand side direction, the object will tend to move towards right side. So here we can give the direction of the friction at this point towards left side, and the friction can be given as F. Also, wherever there is a friction, the normal reaction will be applicable here, represented with N. So in this way, we can say that there are 1, 2, and 3 vertical forces and 1 and 2 horizontal forces. So now if we are going to apply the sigma fx is equal to 0, which is the summation of all the horizontal component forces is equal to 0, given as sigma fx is equal to 0. Collecting all the information about the horizontal forces, there are two horizontal forces. So one horizontal force is P cos 50, that is given here, which is acting towards positive x-axis direction. So we are taking that as positive force. Then second horizontal force is F, which is acting in the negative x-axis direction. Hence, we can take it as negative force. So, minus F is equal to 0. So, there are two horizontal forces in this system given. So, we are placing P cos 50 minus F is equal to 0. Now, if you further simplify this, we can obtain P cos 50 is equal to F. So, which gives 0.64 P is equal to F. From the coefficient of friction value that is given, mu is equal to 0.25, we can write it as F by N. The ratio of frictional force to the normal reaction is mu. Hence, F can be written as 0.25 N. Similarly, we can write P is equal to 0.64 by 0.25. That means we can take the summary as N is equal to here F is equal to 0.25 N. Hence, we can write N is equal to 0.64 P by 0.25. So, take it as 2.56 P as equation 1. Let us consider this equation as the equation 1. Now, let us apply sum of all the vertical component forces is equal to 0. That is, sigma Fy is equal to 0. So, from this, we have already seen that there are 3 vertical forces in this system. So, let us write them down. One force is this weight, which is acting in downward direction. That means the force is negative force. Hence, it would be minus 150. And other force is this P sin 50, vertical component of force P, that is also acting in the downward direction. So, it would be minus P sin 50. Please do remember that all the negative axis forces will be considered as negative forces and the positive axis forces will be considered as positive forces. So, further, another force, that is the normal reaction N, acting in upward direction. So, it would be positive force. Hence, it can be written as plus N is equal to 0. Now, further simplification, we can write it as N minus P sin 50 is equal to 150. Further simplification, we can see that as N is equal N minus 0.77 P is equal to 150. So, from here, we can write it as 2.56 P minus 0.77 P is equal to 150. So, we are writing this N value as 2.56 P, which is taken from equation 1. So, further simplification, you can observe here that P is equal to 150 by 1.79. So, ultimately, the magnitude of the force P can be obtained as 83.79 newtons. So, this is the solution. So, at the end, you can write here that the magnitude of the force P, that is acting at 50 degrees inclination to the horizontal onto the object, is 83.79 newtons. This is the solution for this problem. Now, let us go to the next problem. So, the problem given here is a body resting on a rough horizontal plane. A body resting on a rough horizontal plane. So, let us take a horizontal plane here, and the condition given here is it is resting on this horizontal plane, required a pull of 180 newtons inclined at 30 degrees to the plane. That means from the body, if we apply a 30 degrees inclination force of 180 newtons, which is inclined at 30 degrees, 180 newtons, then the object it will move. And also the second thing it is given is, it is found that a push of 220 newtons inclined at 30 degrees to the plane. That means again the same object, if we are going to apply a pushing force that is also at an inclination of 30 degrees, which is 220 newtons. Okay, 220 newtons to the plane is required just to move the body. So here the understanding of this problem is like this: 180 Newton pulling force at an inclination of 30 degrees to the horizontal tends to move the body, and also 220 Newtons of pushing force at an inclination of 30 degrees also starts to move the body. So here it is been asked that determine the weight of the body and the coefficient of friction. So we can understand here the same body. That means the weight of the body, let us consider it as W, which is acting downwards in first and second case. And also the coefficient of friction value should be known. So this is the problem asked. So what we will do is, first let us consider the first case wherein the 180 Newton force is being applied onto the object, that is also a pulling force. So if we consider this 180 Newton force acting at an inclination of 30 degrees like this, so here it is a inclined force. So what we need to do? We need to consider the components, mutually perpendicular components of this 180 Newton force. So let us take those mutually perpendicular components. The horizontal component would be like this and vertical component would be like this. So this horizontal component value can be given as 180 cos 30, as it is the adjacent to the inclination, and this vertical component will be written as 180 sin 30. So this is the condition of this 180 Newton force, wherein the contact surface, at the contact surface the object is moving, so the friction is prevailing. Hence we can understand that as this 180 Newton is the pulling force, nothing but the object will tend to move towards left side. Hence the frictional value, the frictional force can be taken that in the right hand side direction, opposite to the movement of the object. And the normal reaction, that can be taken as N. This is F1 and N1. As there are two cases, we are considering it as F1 and N1. So now we have obtained all the forces that are acting in the system and the directions. Now we can apply the condition of equilibrium for this given problem. So that would be, first we are going to consider all the horizontal component forces is equal to 0. And this is the condition for the first case. Let us write that also. It is the condition for case 1. So sigma Fx is equal to 0. So in this system, what are the horizontal forces here? So this force, frictional force F1 is one of the horizontal force that we can write here, F1. And this horizontal component of 180 Newton force acting towards negative axis direction, isn't it? So here we can put it as minus 180 cos 30. So these two are the horizontal forces in this system, is equal to 0. So from this we can simplify the value of F1 frictional force as 155.88 newtons. Right? Now let us go to the sum of all the vertical components is equal to 0. So from this we can see there are three vertical components or three vertical forces in the system. One is the weight W, another one is the vertical component of 180 Newton force and the normal reaction N. In these three, the weight W is acting vertically downwards, hence it is a negative force. So for that, we can write it as minus W. So we can consider the values here like W minus W plus N1, which is acting in positive direction, and plus 180 sine 30. So this is also acting in the positive axis direction, so it can be considered as positive force is equal to 0. So further simplification, we can see that W minus N1 is equal to 90 and N1 is equal to W minus 90. Right? So here, if we consider the coefficient of friction value, that is mu is equal to F1 by N1. For the first case, from this we can write it as F1 is equal to mu N1. So that can be taken as we know the value of F1, we can take it as 155.88 is equal to mu into W minus 90. Let us take this equation as equation 1. So here the value of N1 is W minus 90. So we are taking it as equation 1. Now for the second case, wherein the object which is being on the horizontal rough surface and the inclined force that is being applied, that is 220 newtons, inclined at 30 degrees, is being seen and weight of the object is W. Now we know that as the object is moving towards right, because this is pushing force which is acting from left hand to right hand side direction. So it is a common sense that the object will move to right hand side. So the frictional force at the contact surface will be moving towards left hand side. So that can be taken as F2 and the normal reaction is N2. So this is the free body diagram that can be drawn. Now when you consider this 220 Newton force, it is a inclined force. Hence we need to draw the perpendicular components. So coming to downwards and going to right hand side direction. So this component would be 220 sine 30 as it is opposite to the inclination, and this is adjacent to the inclination, so it would be 220 cos 30. So this is the free body diagram of the given system when 220 Newton force is being applied. So in this condition, let us write the equilibrium conditions, that is sigma Fx is equal to 0. So there are again two forces which are horizontal. One is F2 acting in negative axis direction. You can see that it is acting in negative axis direction. So we can take it as negative force. So minus F2. And second one is 220 cos 30, which is acting in the positive direction. So it can be taken as plus 220 cos 30. So these two are the horizontal forces. So that is equal to 0. When you simplify this, you will get the value as F2 is equal to 190.53 newtons. Now let us apply the summation of all the vertical component forces is equal to 0. When you consider this, we can see that there are three vertical forces. One is W, another one is 220 sine 30. Both these are acting in downward direction. Hence, these are the negative forces. And N2 is one vertical force which is acting in positive axis direction. Hence, it would be positive force. So here we can write it as minus W plus N2 minus 220 sine 30 is equal to 0. So from this, if you further simplify, you can observe here N2 minus W is equal to 110 and N2 is equal to W plus 110. Okay. Now also from here we can observe that mu is equal to F2 by N2. So from this, the value of F2 can be taken as mu N2, that is equal to, which implies 190.53 is equal to mu into W plus 110. So taking this as equation 2. Now you can see from equation 1 and equation 2, these two are the functions of two variables. Hence, if we solve these two equations, we can obtain the value of W is 1000 newtons and mu, coefficient of friction mu, as 0.1714. So this is the answer. This is the solution to the given problem. So in this way, by applying the conditions of equilibrium, we have identified the weight of the object and the coefficient of friction value. So at the end of the problem, you can write it as the weight of the object or weight of the body is 1000 newtons and the coefficient of friction value is 0.1714. This is the solution for the problem. Now let us go to the next problem. So in this problem, the figure is given. So first let us understand the problem. The block A shown in figure. So this is the block A shown in figure weighs 2000 newtons. So the weight of the object acting vertically downwards, it is given as 2000 newtons. The cord attached to A pass over a frictionless pulley. This is the cord attached to the body, the block, and which passes through a frictionless pulley and supports a 800 Newton weight equal to 800 Newton. Hence, the value of coefficient of friction is 0.35 is given. Then solve for horizontal force P. We need to identify horizontal force P, and there are two cases given. The first case is if the motion is impending towards left. That means because of this application of force P, the motion should impend. That means this block should tend to move towards left side. And second case is the motion is impending towards right. That means even though the force of P is acting in left hand side direction, the motion should impend towards the right hand side direction. That means all the conditions which are being given here should be satisfying the status that the object will try to move towards right hand side direction. So this is the question given. Now we need to identify the value of P in two cases. So first let us draw the free body diagram for the first case, wherein the object that is placed on this horizontal surface, the weight is acting vertically downwards, that is 2000 newtons, and the force P is acting in the left hand side direction, and there is a tension that is being acted, which is the pulling force of 800 newtons, and the inclination to this 800 newtons is given as 30 degrees. Now in the first case, it is been seen that the object will tend to move towards left hand side direction. Hence, the frictional force will be acting towards right hand side direction. Then the normal reaction N. So this is the case given. Now for this system, let us apply the conditions of equilibrium, that is sigma fx is equal to 0 and sigma fy is equal to 0. So first applying the condition of equilibrium, we can obtain it as N, which is the, let us apply first the condition of equilibrium of sigma Fy is equal to 0. So that would be n minus 2000 plus 800 sine 30 is equal to 0. So here this 800 Newton force is inclined force. So we can write the components of mutually perpendicular components in this fashion, which is 30 degrees inclination. This would be 800 Newtons. So this component would be 800 cos 30, which is adjacent to the inclination, and this is 800 sine 30. So we are considering the vertical forces, hence this 800 sine 30 is acting in positive axis direction, hence we can consider it as positive force, wherein this 2000 Newton vertical force is acting in the negative axis direction, that is vertically downwards, hence we are taking it as minus 2000, and this vertical normal reaction force, it is acting in the positive axis direction, hence it is taken as positive force. Now if we further simplify this, we can obtain the equation as n minus 2000 plus 400 is equal to 0. So this gives n is equal to 1600 Newtons. Don't get confused with this n and this n. This is the normal reaction and this is the units Newton. Now we also have the coefficient of friction value, that is mu is equal to 0.35. Hence we can take it as mu is equal to F by n is equal to 0.35. So this can be written as 0.35 n is equal to F. Take it as equation 1 and this as equation 2. So what we can get, substituting equation 2 in 1, we can identify the value of friction F as 0.35 into 1600, that is equal to 560 Newtons. So the friction value is 560 Newtons and the normal reaction we have obtained as 1600 Newtons. This is the identification with sigma Fy is equal to 0. Now if we apply sigma Fx is equal to 0 for the given system, then we can identify it as minus P, because this P is acting in the negative axis direction, then plus F, the frictional force is acting in the positive axis direction, and plus 800 cos 30 is equal to 0. This 800 cos 30 is acting again in the positive axis direction. So from this we can write it as P minus F is equal to 692.82. So if we simplify this, we can get the value of P as 692.82 plus 560. So that would be 1252.82 Newtons. So this is the force P that is needed for the object to move towards the left hand side direction. Okay, so this is the case, this is the force P that is needed for the object, the movement of the object to start towards left hand side direction, that is left side. Now if we go to the second case, which is the motion is impending towards the right hand side direction, that means first let us draw the free body diagram. This is the block and this is the force P that is being applied and the weight that is being given as 2000 Newtons and the inclined force 800 Newtons that is applied in this direction towards an inclination of 30 degrees. Now comes the difference. The object here now is trying to move towards right hand side direction. Hence, the frictional force will act towards left hand side direction. That is frictional force F. And the normal reaction, obviously it will be acting in the normal direction towards the plane and towards the object. So again here, we can take the components, mutually perpendicular components of 800 Newton force, because this 800 Newton force is an inclined force. So these components can be written as 800 cos 30 and this is 800 sin 30. This 800 cos 30 is in the positive axis direction, hence it can be positive force, and this 800 sin 30 is positive axis direction, hence it is a positive force. But this force F, that frictional force F and force P are in the negative axis direction, hence these are the negative forces. Also this 2000 Newton weight, it is also acting in negative axis direction. Now let us apply, for this second case, let us apply the conditions of equilibrium, that is summation of all the horizontal forces is equal to 0. So with this we can find it as minus P minus F plus 800 cos 30 is equal to 0. Okay, so from this we can write P plus F is equal to 692.82. Here the force, frictional force F is negative force and the force P is negative force, but this 800 cos 30 is positive force, hence the equation is obtained like this. Then P plus F is equal to 692.82, then which implies force P is equal to 692.82 minus 560, that is equal to 132.82 newtons. So this 560 value, the frictional force value, we have obtained in the previous case. So this is the answer, that is 132.82 newtons. So we can observe here that when a force of 1252.82 newtons is applied in horizontal direction towards left side, this object will tend to move towards left side. When we apply this 132.82 newtons in the same left hand side direction, this object will try to move towards the right hand side direction. That is the difference, right? So in this way we have obtained the value of the force P in two cases. So at the end you can write the answer as the force of 1252.82 newtons will impede the motion towards left side, and a force of 132.82 newtons in the left hand side direction will impede the motion of the object towards the right hand side direction. That is the answer you can write. Now let us go to the next problem, wherein the figure is given. Here the question given is two rectangular blocks of weights W1 and W2. These are the two weights that are given, connected by a flexible cord resting upon a horizontal plane and an incline as shown in figure. So here this is the horizontal plane on which W2 weight block is resting, and this is inclined plane on which W1 block is resting. Now, in a particular case, when W1 is equal to W2, that means the weight of both the blocks are same, and the coefficient of static friction being same for all contiguous surfaces, and also the coefficient of friction value is also same. So here the condition given is W1 is equal to W2. So let us take it as weight W, and the coefficient of friction value that is given is mu. Find the angle of inclination of the incline. That means this angle alpha. We need to identify the inclination angle alpha of the incline at which motion of this system will impede. That means this alpha, the angle, when you are applying this inclination angle in the system, the motion of the objects, that is the motion of the system, nothing but these two blocks will impede. That means it will, these blocks will start to move. So for this condition, what we need to consider, we need to identify the inclination angle alpha in the given system. So let us start the problem. As the case given, the two weights in this problem, we are considering the two blocks weight as same. So that means W1 is equal to W2 and we are considering it as weight W. Now let us first take the condition of this inclined block, that is W, which is in a inclined condition. So the weight of the block is acting vertically downwards, that is W. You do remember that this inclined plane, the object that is placed on the inclined plane, for this condition, the forces which are along the plane and perpendicular to the plane will be considered. Okay, so this vertical force, that is vertical weight, the weight which is acting vertically downwards in a normal condition, it is not the proper usage of the force direction in this inclined plane condition. So what we can consider, this W would be an inclined force for this inclined plane condition. Hence, we should be converting this W into mutually perpendicular components, which is normal to the plane and along the plane direction, right? So as the inclination alpha is given here, so the inclination of this W with the normal to the plane condition would be alpha here, and the component values can be taken as W cos alpha and this would be W sin alpha. So these are the components of the mutually perpendicular components of the weight W. Do remember the normal horizontal condition objects or horizontal plane on which the objects are placed. In that condition, we can consider all the vertical forces and horizontal forces. So here, when the object is placed on an inclined plane, we need to consider the forces which are normal to the plane and perpendicular along the plane. So for simple understanding, let us see, this is the normal horizontal plane condition wherein the positive and negative axis are taken like this, positive x-axis and positive negative x-axis. This is positive y-axis and this is negative y-axis. If you twist or turn this total system to some inclination, let us say the inclination is given as alpha. So when you turn the system to an inclination of alpha, what will happen? The system will be turned like this, isn't it? So this would be positive x and this would be negative x. This would be positive y and this would be negative y. So this x-axis direction nothing but along the plane direction and this y-axis plane direction is nothing but normal to the plane direction. So these components will be considered for the problem solving. This is the basic understanding which we have already discussed while considering or studying the friction topic as well as the force topics in the first module. So these are the components of the weight, the horizontal component and the vertical component. Now coming to the force that is being involved here at the cord. So there would be tension that is acting in the system at that cord, and that tension is also will act always away from the object. So the tension T will be acting away from the object. Now we can understand that once the inclination is increased or the plane condition is, the inclination of the plane is being increased, the object will tend to move towards downward direction. So hence we can take that the frictional force, the friction value at this contact surface would be in the up the plane direction. As the object is moving towards downward direction, the frictional force would be towards right hand side direction or up the plane direction. So the frictional force can be taken as in this direction F and or take it as F1 and the normal reaction as here N1. So these are the forces which are obtained in the free body diagram. Now let us apply the condition of equilibrium, that is sigma fx is equal to 0. When you apply this, we are identifying three forces here. One is, here don't get confused that sigma fx is only the horizontal component forces. Here, as the condition is in inclined plane condition, we will be considering it as along the plane direction. So along the plane direction, what are the components are available? This W sin alpha is one of the component which is along the plane. This frictional force, that is F1, that is also along the plane, and this tension in the cord, that is also along the plane force. Hence, these three can be considered, and here we will be taking the directions. F1 is along the positive axis force, hence it is positive force. Then the tension T is also along the positive axis force, hence it is positive force, and minus W sin alpha is equal to 0. This W sin alpha is down the negative axis direction force. Hence it is taken as minus W sin alpha. Now if we substitute the values here, we can obtain F1 plus T is equal to W sin alpha. So take it as equation 1. Now let us apply all the normal to the plane condition components is equal to 0. Normal to the plane, that means the as we have seen the inclined condition, normal to the plane, perpendicular to the plane component forces is equal to 0. When we apply this, we can find the normal reaction N1 which is acting in positive axis direction, hence it would be N1, positive N1, and minus W cos alpha is equal to 0. This minus W cos alpha because it is acting in the negative perpendicular to the plane condition. Hence, we can write N1 is equal to W cos alpha. Take it as equation 2. Now, we also know that mu is equal to F1 by N1. So, from this, we can take, now we are going to consider the condition in the second block, that is W. So, first let us go there. Now, let us draw the free body diagram of this block which is placed on the horizontal plane. For this plane, the weight is considered as W here, and the tension always acts in the outward to body direction, that is T, and the object will try to move towards left hand side direction, isn't it? So the frictional force will again be towards the right hand side direction, that is F2, and the normal reaction, that is N2. So this is the condition given. Also here, mu can be taken as F2 by N2. Hence, we can write it as F2 is equal to mu N2. This is one of the condition. Now, let us write the sigma equilibrium condition, that is sigma Fx is equal to 0. That means all the horizontal component forces in this system is equal to 0. So, how many horizontal forces are there? This is F2 and T. Here F2 is positive because it is in positive axis direction, and T is negative because it is in negative axis direction. Hence, we can write F2 minus T is equal to 0. This gives F2 is equal to T. Also, here from this we can write F2 value as mu N2. Hence, we can write T is equal to mu N2. Take it as equation 3. Now, if we apply summation of all the vertical components is equal to 0, we can say it as N2 is equal to W. N2 is equal to W. So, further simplification, we can see in equation 3, if we consider this equation 3, if we put this N2 value there, we can write it as T is equal to mu into W. So, from this equation 3, value of N2 is taken as W. So we are considering this as equation 4. Now what we are doing, let us take the starting equation, that is equation 1, which we have selected. The equation is like this: F1 plus T is equal to W sine alpha. This is from equation 1. This is from equation 1 we are writing. So if we substitute all the values that we have obtained in from the equation 1, 2, 3 and 4, we can consider here the value of F1, that is from given condition, that is mu n1, where we have obtained mu is equal to F1 by n1. So mu F1 is equal to mu n1 plus T is equal to W sine alpha. Then if we further simplify this, we can write mu W cos alpha plus T is equal to W sine alpha. This is being taken from equation 2. Okay. Now further simplification, mu W cos alpha plus mu W is equal to W sine alpha, and this is been taken from equation 4, which we have obtained previously. Now we can write mu into W. That means the mu W combination we can write mu W into cos alpha plus 1 is equal to W sine alpha. From this we can cancel this W from left hand side and right hand side. So we can obtain this mu value as sine alpha by cos alpha plus 1. So this can be further simplified like sine 2 theta formula and cos square theta formula. We can simplify this as 2 sine alpha by 2 and cos alpha by 2. By this cos alpha plus 1, it can be written as 2 cos square alpha by 2. This is the trigonometric formula which we can obtain. Hence, cos alpha by 2 and cos alpha by 2 can be cancelled, and 2 and 2 can be cancelled. So from this we can write it is as tan alpha by 2. So here we have obtained mu is equal to tan alpha by 2, where alpha is the inclination of this plane. Further, we can understand that this mu can be written as tan phi, which is the friction angle. So tan phi is equal to tan alpha by 2, or else we can write alpha phi is equal to alpha by 2. From this further we can write alpha is equal to 2 phi. So this is the inclination, where phi is the friction angle. So for the given condition, we can give the answer as, when this alpha value is twice the friction angle, then the weight of the object W, which is given, when both the objects' weight is same, then the movement will impede. That's the value we can give. So as the answer you can write the value of the inclination alpha is 2 phi, which is the twice of the friction angle. Or else you can directly answer this till here. Tan alpha by 2 is equal to mu, where mu is the coefficient of friction. This completes this problem. Now let us go to the next problem, where this problem is related to the ladder. So according to the given problem, there is no figure that is given. So we can draw the figure simply by studying this problem. The problem given is a ladder 6 meter long. Let us draw the condition of the ladder here. This ladder, there is a wall and ground, and there is a ladder placed here, and the length of this ladder is given as 6 meters. Length of the ladder is given as 6 meters, and with 300 Newton weight. So the weight of the ladder, which will act from center of the ladder, we can give it as 300 Newton from here, is resting against a wall at an angle of 60 degrees to the ground. So from the ground, the inclination is given as 60 degrees. and a man weighing 750 newtons climbs the ladder. So a man who is weighing 750 newton is climbing the ladder. At what position along the ladder from bottom? That means from the bottom, when the man is climbing up, climbing up, at what position along the ladder from bottom does he induce slipping? That means at what position, to what height extent the climbing of the man will induce the slipping of the ladder, we need to identify. So let us take that as the distance x. Let us take that distance as x, and the weight of the man that is standing here, it is given as 750 newtons. And the coefficient of friction for both wall and ground with ladder is 0.2. So there is a friction that is prevailing at the contact points here and here. Let us take those points as A and B. So let us draw this ladder figure clearly once again. So for this ladder, the length of the ladder is given as 60 degrees or 66 meters, and the inclination is given as 60 degrees. The weight of the ladder is acting downwards, which is 300 newtons, and the man weight is given as 750 newtons. So this distance we are taking it as x meters, and from the center we can consider it as the distance half of the ladder, that is 3 meters. So this point B and this point is taken as A. So when the ladder slips here at point A, it will try to slip towards right hand side direction. So we can consider the friction towards the left hand side direction, take it as FA, and the normal reaction NA. Also at point B, what happens? The ladder will try to move towards downwards. Hence we can consider the friction in the upward direction, that is FB, and the normal reaction, that is NB. So this is the free body diagram for the given problem. We can understand here that the coefficient of friction value, that is at point B, it can be written as FP by NB. So this will give the value of FB as 0.2 NB. Also at point A, we can write it as coefficient of friction given as FA by NA. So from this, the value of FA is 0.2 NA. So this is the given data. Now let us start the problem. Now applying the summation of all the horizontal component forces is equal to 0, we can identify it as NB minus FA is equal to 0. As you can see, this NB is the horizontal force and FA is the horizontal force, and other things are vertical. Hence, we can write from here as NB is equal to 0.2 NA. Now let us consider the sum of all the vertical component forces is equal to 0. So from this we can write NA plus FB minus 300 minus 750 is equal to 0. So how we have obtained this? This NA is acting in positive direction, this FB is acting in positive direction, and this 300 and 750 both are acting in vertically downward direction, that is negative axis direction. Hence these are minus 300 minus 750 we have taken. So from this we can continue, wherein NA plus 0.2 NB, which is being taken from this equation, and FB is taken as 0.2 NB here and is equal to 1050. Then further simplification, we can take it as NA plus 0.2 into 0.2 NA. So this NB value again taken as 0.2 Na from here is equal to 1050. So from this we can write Na is equal to 1009.6 newtons. So this is the value of Na which we have obtained. So if we substitute this Na value in this equation, we can obtain the value of Nb as 0.2 into 1009.6, that can be taken as 201.92 newtons. So this is the value of normal reaction B. Right? Now we have obtained Na and Nb values. Now for further simplification, what we are going to do is, we are going to consider the moments. We are going to consider the moments of the system with respect to A. Whatever forces that are acting, we are going to take them Fa and Na. This is 300 and this is 750, and the distances which we are obtaining, we will be considering them. This is 6 meters, this is x value we are taking, and this is 3 meters. So when we apply the moments with respect to moment center A, that is sigma ma is equal to 0, that will be obtained as, first the force 300 newtons, which is giving anti-clockwise movement considering this moment center. Hence we will be taking it as negative moment. So minus 300 into 3 cos 60. Then again this 750 will also give the anti-clockwise direction. Hence it will be taken as minus 750 into x cos 60. How this 3 cos 60 and x cos 60 has been obtained? Very simple. We are considering the right angle triangle here, and a trigonometric ratio is been applied. For example, if we consider 300 force, this 300 force is lying at a distance of, right, we will be considering the force into perpendicular distance from this point A, isn't it? So from this point A, we are going to consider the perpendicular distance here. That means we need to identify the distance here. We already have the value of inclination, that is 60 degrees here. So the distance to which this position, that 300 acting position and this bottom position, this distance can be obtained by simply applying the cos theta. That means cos 60 degrees will be giving the value of, let us take this as L, the value of L by this hypotenuse value we know. How much is this hypotenuse value? It is half of the ladder, so we can take it as 3. So the value of L is obtained as 3 cos 60. So this is simple trigonometric multiplication or trigonometric calculation. So from this, let us go further. Next force would be the NB force, that is acting here. This NB force, it is giving a clockwise movement, right? So this clockwise movement, as it is giving a clockwise movement, we can consider this NB force as the positive force. Hence this is plus NB into 6 sin 60, right? And then further another force is FB. This FB, which is again giving the positive, that is clockwise movement. Hence it would be a positive movement. Hence we can write FB into 6 cos 60 is equal to 0. Now if we simplify this equation, we can get the values like this: minus 450 minus 375x plus 1049.2 plus 40.384 is equal to 0. Hence, if we further simplify this, we will be obtaining 375x is equal to 639.584, and the value of x, the distance to which the man is standing, is 1.706 meters. So this is the solution, and you can write the answer as the slippage of the ladder will induce when the man reaches to the length of 1.706 meters from the ground. So this is the solution which you can mention. This completes this problem. Now let us go to the next problem, which is given as the wedge friction problem. So the problem given is a block of mass 150 kg is raised by a 10 degrees wedge. Here, as you can see in the figure, this block of 150 kg is raised by this 10 degrees wedge under it. And this wedge weight is also given, that is 50 kgs. The wedge weight is also given as 50 kgs. And by applying a horizontal force P, so the force P is being applied here and it's at its end, taking the coefficient of friction between all the contact surfaces. Here, first let us understand how many contact surfaces are there. See, for this block of 150 kg, it is getting in contact with this supporting wall, and this wedge is getting in contact with the floor, and the third condition is, or the third contacting surface is the contact surface between the block and the wedge itself. So this is also a contact surface. So these three contact surfaces, the friction will be prevailing. We need to understand that first. And the value of the coefficient of friction that is given at these three contacting surfaces is 0.3. Now, it is asked to find minimum force that should be applied to raise the block. So what is the force that should be applied for raising the block? The minimum force. That means, again, we should understand that the motion needs to be impeded. The motion needs to be impeded. So that is what the question is asked. Now let us solve the question. First, let us draw the free body diagram of this 150 kg block. First, before doing that, let us convert this 150 kg to the SI units weight, that is W is equal to 150 kg mass into 9.81 acceleration due to gravity, that will be obtained as 1472 newtons. So, while drawing the free body diagram, we can draw it as the weight that is acting of 1472 newtons downward direction, and at this contact surface we can show the frictional force in the downward direction. Why we are showing this frictional force in the downward direction? That is because when you consider this block alone, when we are trying to push this object towards left hand side, this block is trying to climb this body that is below it. It is trying to climb the body below it. So the movement of that block is towards the right hand side direction. Hence, the friction can be taken in the left hand side direction or downward direction, and the normal reaction, that is N1. And the inclination that is given here is 10 degrees. Inclination that is given here is 10 degrees. So overall, this is at the contact surface, the friction and normal reaction. Now coming to the another contact surface, that is this position. Here, the object is trying to move in the upward direction. Hence, the frictional force will be towards the downward direction, that we can take it as F2. And the normal reaction is N2 shown here. So this is the free body diagram of the given condition. Now let us start the problem. Here the mu value for first contact, that is F1 by N1, we can take it as F1 is equal to 0.3 N1. F1 is equal to 0.3 N1. Now let us apply the, for this block, let us apply the summation of all the vertical forces is equal to 0. When we doing this, so we will be obtaining the values. Now as you have understood how the positive and negative forces are taken, let us go in a further proceedings how we are going to do that. That is N2 minus F1 cos 10 degrees minus N1 sin 10 degrees is equal to 0. Here the components of F1 and N1 are taken as these two are happening to be an inclined force. How we are considering for F1, which is shown here like this, the components would be in this direction, isn't it? So this would be a vertical component and this would be a horizontal component. And coming to N1, which is acting in this direction, the components would be taken in this horizontal direction and vertical direction, and the inclination that is 10 degrees is given here. As it is a simple triangular for theorems, we can understand that the inclination of 10 degrees will be obtained here. So further simplifying this, we can obtain the values as N2 minus 0.3 N1 into 0.98 minus 0.17 N1 is equal to 0. So further simplification, N2 minus 0.29 N1 minus 0.17 N1 is equal to 0. So further, N2 minus 0.46 N1 is equal to 0, and from this we can obtain N2 as 0.46 N1. So take it as equation 1. Now what we are doing, we are applying for this similar free body diagram, we are applying the summation of all the vertical components is equal to 0. So for doing that, we are going to see sigma Fy is equal to 0. So from this free body diagram which is being shown, do remember that we are going to write the sigma Fy is equal to 0 condition, equilibrium condition. So those values would be minus 1472 minus F2 minus F1 sin 10 plus N1 cos 10 is equal to 0. So further simplification, we can see it as minus 1472 minus 0.3 N2, then minus 0.3 N1 into 0.17 plus 0.98 N1 is equal to 0. Right? So these are the values that are being applied by substituting the values of F1 and F2. Now further, we can see minus 1472 minus 0.3 N2 minus 0.051 N1 plus 0.98 N1 is equal to 0. So further simplification, we can see it as minus 1472 minus 0.3 N2 plus 0.929 N1 is equal to 0. Further, we can take 1472 minus 0.3 into 0.46 N1 because we already know the value of N2 as 0.46 N1, then plus 0.929 N1 is equal to 0. So all these substitutions and calculations simplification can be observed here. Then minus 1472 minus 0.138 N1 plus 0.929 N1 is equal to 0. So from this we can write the value of N1 as 1472 by 0.791, that is 1860.94 newtons. So in this way we have obtained the value of N1. So from here we can understand that by substituting this N1 value, In equation 1 which we have already taken here, the equation 1, we can get the value of N2, isn't it? So that will give N2 is equal to 0.46 into 1860.94. So that can be obtained as 856.03 newtons. Also, we have F1 value as 0.3 N1, isn't it? So the value of F1 can be taken as 1860.94. So that is 558.282 newtons. So this is the value of F1. So in this way, from the case 1, wherein we have seen the free body diagram of the block and we have solved the values, we have obtained the values for the frictional force F1 and normal reaction N1. These would be helpful for further simplification when we are going to do in the wedge, the free body diagram of the wedge. Let us see the free body diagram of the wedge here. Consider the wedge that is given. There is this the wedge which is of 10 degrees and force P is acting towards left side as shown, and the frictional force at the contact point. Here now again we need to understand that in which direction the frictional force will act, that is F1 and Fn1. The frictional force here is being shown in the up the plane direction. Why? Because the movement of the wedge is from right hand side to left hand side direction. So at the contact surface, the frictional force will be acted towards up the or right hand side direction. And at the contact point here, the frictional force again, let us consider it as F3 at the third contact, and the normal reaction will be N3 as shown here. Also the weight of the object, the weight of the wedge is also given, which is 150 kgs. So let us first change this weight of 50 kgs to the SI units of Newton, that is 50 mass into 9.81, that is meters per second square. So that will be obtained as 490.5 newtons. So this 490.5 newtons can be taken in the downward direction, which is 490.5 newtons. So these are the forces which are seen here. And now let us understand the inclined forces that are F1 and F2. Let us see them as the component forces. First N1. N1 is acting like this. So the component forces would be vertically downwards and towards the right hand side. And the inclination is 10 degrees here. So this component would be N1 cos 10 and this component would be N1 sin 10. Coming to the frictional force F1, we can consider it as shown here. The force as in this direction, this would be F1 and the values would be, this is 10 degrees, hence the frictional force components would be F1 cos 10 and this is F1 sin 10. So these are the component forces of the frictional force F1. Now let us solve the problem by applying the sum of the all the horizontal components is equal to 0 and sum of the all the vertical components is equal to 0, which are the conditions of equilibrium. So first let us do sigma Fx is equal to 0. So all the forces which are horizontal in this total system we are considering, those will be minus P plus F3 plus F1 cos 10 plus N1 sin 10 is equal to 0. Now let us further simplify this. We will obtain minus P plus 0.3 N3 plus 558.28 into 0.98 plus 1860.94 into 0.17 is equal to 0. So further we can see minus P plus 0.3 N3 plus 547.11 plus 316.36 is equal to 0. So further simplification, we can obtain the equation as minus P plus 0.3 N3 plus 863.47 is equal to 0. Let us take it as equation 2. Now applying the sum of all the vertical forces is equal to 0, that is sigma Fy is equal to 0. That implies minus 490.5 plus N3 minus N1 cos 10 plus F1 sin 10 is equal to 0. Now further simplification, we can see here that minus 490.5 plus N3 minus 1860.94 into 0.98 plus 558.28 into 0.17 is equal to 0. Further, we can write it as minus 490.5 plus N3 minus 1823.72 plus 94.9 is equal to 0. And from this, we will obtain the value of N3 as 1823.72 plus 490.5 minus 94.9, that is equal to 2219.3432 newtons. So this is the value of N3. Now further, if we substitute this value of N3 in this equation 2, the value of N3, if we substitute this value in equation 2, we will directly obtain the value of P. So when we substitute this, P would be 0.3 into 2219.32 plus 863.47. So that would be 665.796 plus 863.47. Hence, the value of P can be taken as 1529.266 newtons. So this force of P, if we apply to the wedge from the right hand to left hand side direction, then if we apply this force onto the wedge, the block of 150 kg, it would be having a impending motion towards the upside direction. So these are the important problems in our module 2 of tutorial question bank. This concludes this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.